Hello students, today's lesson is on kinetic energy and elastic potential energy. Kinetic energy and elastic potential energy are different forms of energy. However, their formulas for calculating these energies seem similar, as you will see in the video. When we say kinetic energy, what do you think that is? Well, kinetic energy is the energy found in moving objects. When a body is in motion, you get kinetic energy. That does not mean that when an object is in motion, there's no other forms of energy. But when the object is in motion, it means the greatest form of energy is the kinetic energy. There could be other forms of energy, but they are very minimal. What is elastic potential energy or elastic energy? This is energy stored in elastic objects. For example, springs, elastic bands, anything that can stretch has elastic potential energy or can store elastic potential energy. So on your screen, we need to describe in details what you're seeing happening to the ball. What do you think is happening to the ball? The ball, and think about the energy changes, okay? So we can say that the ball is rolling down the hill, and as it rolls down the hill, the energy stored, which is the gravitational potential energy, is changed into kinetic energy. That doesn't mean that there's no gravitational potential energy, but as it falls down, it speeds up, and as the speed increases, the gravitational potential energy decreases as the kinetic energy increases, okay? So we're going to move on to the targets. If you're aiming at grade 4, then you should be able to state the factors that affect the size of the kinetic energy. You should be able to also state the factors that affect the size of the gravitational potential energy stored in a spring or an elastic object, and then be able to describe the energy change that involves gravitational potential energy and kinetic energy stores. If you're aiming at grade 6, you should be able to calculate kinetic energy stores of an object and also be able to calculate elastic potential energy source of an object. If you want to be at grade 8, then you should be able to make the subject of the formula of the gravitational potential energy and then the elastic potential energy. Basically, you should be able to find the velocity of the gravitational potential energy, or you should be able to find the extension of the elastic potential energy. To do this is quite involving, so that is for grade 8. Now, in one of our videos, we talked about work done and energy. We said that energy is the same as work done. But when we talk about work done, you only do work when a force has been applied. So first of all, you can say work has been done after applying the force. Applying the force is not just doing work, but that force should be able to move an object over a distance. So if you apply a force and the object doesn't move, there's no distance moved, then the work done is 0. So although you've applied the force, but there's no distance moved. So basically you haven't done nothing, because we want the force to be able to move a certain object. Once the force hasn't been able to move it, work done is 0. Okay? So work done is force times distance, or work done is basically the amount of energy transferred. So moving side by side or side to side from the image on your screen, imagine pushing a cart with very well-oiled wheels, no friction. The speed of the cart will increase while the force acts. So work done is the same as the change in kinetic energy, because the force is able to move the object over a distance. Okay, so the work done is a change in the kinetic energy of the car. So the work done, the kinetic energy of a moving object depends on two things. It depends on the mass, how big the object is, and then the speed. So if you have a bigger object, it's very difficult for you to get the object to speed up because it's massive. But if you have a smaller object, then the object can move quicker, like bullet. Bullet has smaller mass. It can move very quick at a high speed. That's why the bullet can penetrate into bodies. If the bullet was bigger in terms of mass, it will not be able to penetrate. So in such situation, a bullet has a small mass, but high speed, it moves faster. Okay, so the kinetic energy of a bullet is high, and it is the reason why it is high for a bullet is because it's moving at a faster speed. Okay, a kinetic energy also depends on the speed at which the object is moving. So if the object is moving fast, there's more kinetic energy. If the object is moving slow, there's less kinetic energy. So the kinetic energy is equal to half times the mass times the velocity squared. That's the formula for kinetic energy. Half, to make it simple, you write 0.5 times mass times velocity squared. When you're doing this calculation, especially if you're in a bottom set, you first of all have to do the V squared, use bit mass. Okay, in maths, bit mass, you have to do the square first, the power first. So if you do the power first, then you multiply your answer by the mass, then you multiply the answer by 0.5, or you have whatever you got. That gives you the kinetic energy. So if you look at the formula, which of these factors has more impact on the kinetic energy? If you look at the formula, the velocity is squared, but the mass is not squared. So which means that the velocity has more impact on the kinetic energy. When you increase the velocity by 1 unit, it could generate 4 times increase in the kinetic energy or more, depends. Okay, so every moving object, the speed is what greatly determines how much kinetic energy it has. So the bigger the speed, the larger the speed, the more the kinetic energy. So which means that the velocity has more impact on the kinetic energy than the mass. Why? Because the velocity is squared. Okay, so now we are going to take some few questions. So a car has a mass of 500 kg moving at the speed of, or the velocity of 20 meters per second square. Sorry, 20 meters per second, my bad. Okay, so what you're going to do here is that you multiply the mass, you find the square of the speed. 20 square is 400, 400 times 500, and then you half it. So 400 times 500 is 20,000. Half of 20,000 is 10,000. So A, the answer will be 10,000 or 100,000. Okay. And then for B, let's go back. So for B, you have 1,000 as the mass and then 10 as the speed. So you do 10 squared first, which is 100. 100 times 1,000, and then you half it, and that gives you 50,000. Okay, so first of all, remember you do the square first. So the first one, 20 squared is 400. 400 times 500 is 200,000, and then half of it is 100,000. So from this example, you realize that the second car has more mass and then small speed, the second car, whereas the first car has small mass and more speed. You realize that the first one gives you more kinetic energy than the second one. Why? Because the speed makes more difference. There's more the speed, the greater the effect. So you could see that the speed, if you check question number 1 and 2, it was 10, it increased to 20. So the speed was doubled. From 1 to 2, the speed has decreased. But has decreased by half, because from 20 to 10 is half of 20, that gives you 10. And then when that happened, you get more effect, because if you look at the mass, you've got 500 increasing to 1,000, but it doesn't have that kind of effect. Okay, so the speed makes that big difference. Question 1 has more speed and less mass, more kinetic energy. Question 2 has more mass, less speed, smaller kinetic energy. Okay, that's what I want you to be aware. The speed makes the difference. Okay, now, sometimes for grade 8, you'll be called to make M the subject, or to find M the mass, or sometimes find the velocity. In this case, you have to rearrange the formula. Okay, so now you have, okay, so we have this formula. So what we're going to do here is to make M the subject. So to make M the subject, you are going to divide. Okay, let me write it this way. That makes it easy for you to understand. So KE is equal to 0.5. I'm using 0.5 instead of half so that you will understand this easier. Okay, times mass times V squared. So we're making M the subject. Okay, so if you're making M the subject, you are going to divide all of this by 0.5. And then V squared. Okay, so whatever you do to the right, do the same thing to the left. So 0.5 times V squared. Okay, so this will cancel out this. So that is gone. This also takes away this. So you're gonna get KE kinetic energy divided by 0.5 V squared is equal to mass. Okay, so now M is the subject. So now you can find the value of the mass by dividing the kinetic energy by 0.5, and then you times it by the square of the velocity. Okay, so sometimes you could be also asked to find V, and if you're able to find V, that is grade 8. Brilliant. The same principle. So we're gonna make V the subject. So we have our KE is equal to 0.5. I prefer using 0.5. Why? Because it's pretty straightforward. There's no fraction here. It makes it easier for you to do the calculations without having any difficulties. So I prefer to use that one when I'm teaching. Okay, so now we're going to make V the subject. So we divide all of this by that, and then all of this by that. Whatever you do to the right, do the same thing to the left. So we put 0.5 times V times M, sorry. And then this will be 0.5 times M. So this M takes this away, this 0.5 takes this away, So you're gonna get KE over or divided by 0.5 times M is equal to V squared. We want to make V the subject, not V squared. So what's the opposite of square? Opposite of square is a square root. So you're gonna square root both sides. Okay, you're gonna find the square root of both sides. So that square root and the square goes away. So you're gonna have V is equal to KE over 0.5 times M. Right, remember, there's 1 here, we don't bring. So 1 over 0.5 is the same as 2. Okay, so we can also put 2KE over M, but just keep it simple as this. Okay, so that's the formula for finding the velocity of kinetic energy. Right, we're gonna move on to the next slide. So answer the kinetic energy questions in your book. That's a task that you could do, but we'll move on and then we'll do the task finally at the end. So now let's move on to stretching objects. Stretching objects are any object that can stretch, and any object that can stretch, like bungee, rope, or spring, it stores elastic potential energy. So if you look at this picture, it is a bungee jumper. It's an example of gravitational potential, sorry, it's an example of elastic potential energy. So when energy transfer happened to the bungee jumper after bungeeing the platform, when the rope is slack, the energy is transferred from the gravitational potential energy store to kinetic energy store as the jumper accelerates towards the ground due to the force of gravity. So once the person is moving downwards, there's energy transfer because the rope is stretching. So when the rope stretches, it releases the elastic potential energy stored. When the rope goes back to its original shape, it has reclaimed the energy. So it's now storing energy. When it's stretching, it is releasing the energy. Okay. All right. So we could do some investigation of bungee jump. That's not my focus today. My focus is for you to be able to use the formula for elastic potential energy. Now, elastic potential energy is also half times spring constant times extension square. Now, right, if you listen to the beginning of the video, I told you that the formula for elastic potential energy is similar to the formula of kinetic energy. That is why we are doing this together. So E, elastic potential energy, is equal to 0.5, that's a half. K is a spring constant, and then E square. Whereas if it's kinetic energy is half mv squared, but this one is half ke squared, a little bit of similar. Okay, so it's the same way we make the subject. If you want to find the k, you are going to divide EP by 0.5 e squared, just like the one we did. And if you want to find the E, then it's going to be EPE divided by 0.5 K or square root. Okay. Right. So we're going to move on. The energy transfer, we know that. So that's the energy stored, half Ke squared for elastic potential energy. So now If you want to find out how much kinetic energy that is the rope is stretching, then you have to equate the kinetic energy formula and the elastic potential energy formula. So half mv squared is equal to half ke squared. So if you do that, then the half will cancel each other. The half will cancel each other. So what you're going to have is mv squared equals to ke squared. Okay, so let me explain a bit further. So this cancels out this. So you have mv squared equals to ke squared. So if you want to find the mass, you divide here by, if you want to find the mass, you divide here by v squared, and then you divide here by v squared, and then this mass, the mass will be m is equal to ke squared over v squared. Okay. For GCSE, you may not be, probably they could ask you this question for grade 9, but you just have to know it. If you, a bungee jumper is jumping and then you want to work out the kinetic energy or the mass, then you have to use this formula. You equate the kinetic energy to the elastic potential energy, and then you make M the subject, just as I have done on the screen. Thank you. So these are the questions that we need to have a look at, and I will entreat you to do them during your leisure moment. These questions are the next on the next slide. So these are very easy questions. You can pause your video, do all of them, and then you can mark it yourself. They are pretty straightforward. You shouldn't get any problem with that. The last question, it involves spring constant. It also involves elastic potential energy. So you need to be able to, it says calculate the elastic potential energy. It's giving you the spring constant and extension, very easy. You should be able to do that. So this is our topic on kinetic energy and elastic potential energy. Let's summarize it. So first of all, you should know that the kinetic energy depends on the mass and the velocity, but the velocity has more impact on this kinetic energy than the mass. The formula is half times mass times the velocity squared. That's the formula for kinetic energy. Now, elastic potential energy depends on the spring constant. Okay, it depends on the spring constant. It also depends on the extension. Okay, the more the extension, the more the elastic potential energy released. Okay, and the formula for elastic potential energy is half k squared, half ke squared, half ke squared. Okay, so if you're able to rearrange and find either K or E, or you can find M or V, then you are working on grade 8. I hope this video is helpful, and just please do the questions. Thank you very much. I'm gonna meet you again for the next video, which will be on work done and gravitational potential energy. Thank you. Bye.